Awesome.
Hello, everyone. Good morning. Good morning. Thank you for joining us again in a new event from Data Tech Florida. In this opportunity, we have an amazing woman, an amazing speaker. It's my fault in my company in Albany. It's Mo. Mo actually is group manager, expert in many analytics tools. Well, today we have this session about the data platform 900 fundamentals certifications. Welcome all. How are
Thank you.
you?
I'm good. Thank you, Nick, for introducing me. That was very nice and kind of you. Good morning, everyone. It's a Saturday morning. I know before the long weekend, most of you are probably still catching up on your sleep. But if you can attend this or you can watch it later, that'll be great. My name is Mo Rakshit. Nick is my colleague, and he introduced me to this, meetup and platform so I can share my knowledge with you all. I've been working in data platform for about 26 years. I specialize in all things related to data, particularly in Azure, Microsoft Cloud, and in Azure Databricks. So we'll go through this. This is basically the introduction and to get you prep for the DP 900 course, which is the fundamental on Azure data. And we're going to learn some things. There's a lot of topics to cover, 1.5 hours. There's some lab that you can do after the class, or the time for the class won't permit those, but we'll see what we can do. So shall I get started, Nick?
Yes. Go
Yeah.
ahead, Mo. Okay. See you.
Sure. Thank you. Okay, so guys, we are going to explore the fundamentals of data analytics. So number one is large scale data analytics. As the data volume increases, obviously, the data will scale, right? So your analytics platform has also be able to accommodate that. So we call that big data analytics, right? Then streaming and real-time analytics, that would be our second topic, which is, when the data is coming from your IoT devices or operational databases as change data capture continuously coming as an unbounded stream. You'd like to get the insights from that data and be able to process it and store it in your platform and be able to do visualization as well as machine learning modeling and on top of it, right? So that's the other topic that we're going to cover, which is streaming and real-time analytics. And then the third one is data visualization. Obviously, for the analyst or even business practitioners or anyone, a human being consumes the information best way through visualization, right? So visualization helps you to get to the insights from the data. So we're going to cover a little bit on that one as well. So let me see, where is the clicker? Okay, so I have multiple monitors, which is it's kind of okay. So objective, you're able to see, objective is so after completing this module, you'll be able to describe the common features of large-scale analytical solutions, common features of real-time streaming analytics, as well as data visualization. Now, next, let's go to the first topic, which is large-scale data analytics. So if you think about the data flow, elements of the large-scale big data analytics solution, basically your first step is to bring the data to your platform, analytics platform, right? Whether you are building a lakehouse in Delta or any other format in Azure, you're going to be ingesting the data, that we call it data ingestion. And you bring the data, traditionally you might be aware of ETL and ELT, which is extract, transform, load, or extract, load, transform. Either way, you're extracting the data from your source system. It could be on-prem, could be other operational databases, it could be legacy system, it could be from cloud object storage, and you're bringing it into the analytics platform by extracting and then transforming and then loading it here, right? Or you can do extract and then load and then do the transformation after the data is loaded in the bronze layer. So either way, basically your goal is to make sure you can bring all of the data from all kinds of sources into your analytics platform. And also you need another component of big data analytics or large scale analytics is compute processing engine, right? So distributed processing, you need a distributed processing architecture to be able to process this large volume of data from all kinds of sources, to be able to cleanse it, standardize it, restructure it, build a dimensional data model on top of it. And then you also need to be able to do both batch and streaming. So when I say real time, here it's mentioned real time. So real time meaning it is streaming. It could be near real time, it could be real time, but there are different modes in which you're going to be bringing your data in. It could be on a schedule basis, which is batch mode. It could be every hour, every 6 hours, every day, or it could be continuous fashion in every second, every millisecond, and whatnot. So your goal is to bring the data from all kinds of sources, your operational databases, into your analytics platform. You also need the distributed engine to be able to process that data first, and you need a scalable, flexible storage layer. We call that basically Delta Lake if your data files are stored in a Delta format, or Data Lake traditionally, right? So, or you might be storing it in a relational table in your lakehouse, data lakehouse, which is a structured row columnar storage for data warehouses for business intelligence analytics workload. And then on top of it, once you stored the data, you cleansed it, you ingested it, standardized it, and then build a dimensional data model on top of it. Then you're going to be actually creating your semantic model. We call that dimensional model. It could be star schema, it could be snowflake schema. The goal is basically to make the data in a format which is easier to consume by the analyst or ad hoc. For if somebody wants to do streaming analytics, or create some visualization, or do ad hoc analytics, mostly those are analysts or your business practitioners or anybody within the organization. So in order to present that data for visualizations, it needs to be formatted in a fashion which is consumable for those type of analytics. So here we are talking about that semantic model, which is your facts and your dimension that we're going to talk about, which is basically your data is aggregated in different grains so that you can slice and dice the data and be able to visualize it. So those are the few pillars of your big data analytics or large scale analytics solution. When it comes to data processing, there are two options. One is relational databases. So these are traditional, you might be aware of, or you have worked on in the past in Oracle, SQL Server, MySQL, PostgreSQL, and Teradata, etc. Those are all relational databases. They store the data in a normalized, structured, row columnar fashion, right? It is a well-established model. Your data model is normalized, meaning the normalization concepts, right? That's basically your goal is to reduce data redundancy, make sure that data is integral and it's related to each other with primary key, foreign key, and whatnot. And that type of relational databases is actually optimized more for your DML statements, which is insert, update, delete, and whatnot. It also has a comprehensive support for read workload as well. So in order for you to process the data, you can either use relational engine, relational databases, which is a well-established model for relational data storage, which is structured row columnar data. And it also has a comprehensive support for SQL language in order for you to do data manipulation as well as read from the data. And then the other compute engine is basically your Apache Spark, which is open source platform for distributed data processing. What that is basically under the hood, it's a cluster, a node of multiple nodes of computes all working together. There will be a driver node and multiple worker nodes, and the data is partitioned and sent distributed to different workers so that they can all work parallelly and give you the best performance or faster processing, right? So that's the goal of Spark, distributed parallel processing engine. It also has support for all kinds of languages, not only SQL, but Python, Scala, and Java as well. Okay. So now, analytical store architecture. So how do you design the data model within your analytics data store? Traditionally, you might have used data warehouses, and here also you will see you'll be able to use data warehouses where the data is stored in a relational databases, which are structured row columnar, as I was mentioning, and it is queried through SQL query language. Tables are denormalized for query optimization. In this case, we are talking about completely structured data. And you can, in order for the analytics workload to perform well, you can denormalize the data model. What is denormalization? I mean, you don't normalize it. Traditionally, your operational databases will be normalized, but your analytics platform, you're going to be denormalizing it because there your goal is to improve the performance of queries, right? So that it can read massive amount of data and be able to present the information to you quickly. And in that case, and you also would like to slice and dice the data in different dimensions. So here you're in the center is your facts, and then all the dimension tables are associated with your facts. To the facts table, facts is your transactions. Dimensions are your like product, supplier, customer, etc., location. You can think of that way. So dimension gives a context to the transaction data. And that is that star schema model, and it's also a denormalized model. Your goal in the analytics platform is to reduce as much as join need to be done as much as possible. Why? Because joins are expensive operation. It costs performance issue, it costs latency, right? So you would like to get the data faster, and you're talking about a massive amount of data in analytics platform. So your data model would be normally denormalized. For query optimization, it could be star schema, which is looks like a star. In the center, it's the fact table. In all the other, just like your the dimensions are going to be connected to the to the fact with uh, linking, which is primary key foreign key relationship. Even though we don't enforce that relationship in data warehouses, but that is how the model will look like, so that you can slice and dice the data and look into the facts based on different dimensions. So that is your data warehouses. And data lakes are traditionally stored in a distributed file system, meaning underlying data is stored in files, and that we call it data lake, right? Typically, it is processed with the Apache Spark parallel processing engine, that distributed computing engine that I was talking about, where you have a driver node, like you have multiple nodes of clusters of virtual machines working together. One of the node is going to be the main node, which is the driver, and there will be multiple worker nodes. And the goal is to basically get the processing done in a faster fashion, in a parallelized fashion. And how does the Spark gets that parallel processing is through that it distributes the data partitions to different worker nodes. The driver does that. It's main coordinator, and then gets the work done by multiple processing nodes at the same time, and then moves on and it does the next step, etc. Driver manages the work. Finally, the results are delivered back to the client window, which is issuing the commands or anything. It is also metadata is a part of the table definition, is used to define the tables. You can use relational SQL interface to read the tables. Normally, these tables are stored as Delta format. There are many other formats possible, Parquet, ORC, JSON, etc. But primarily, the two open source format which are widely used, and particularly for Azure Databricks and then also for Microsoft Fabric, you will see Delta is the predominant format. And it's also an open source format. You can go to delta.io. You'll be able to see all the release notes and what's the features and what are there are numerous things that Delta provides. Delta format provides, which is time travel, ACID transaction guarantee, and then many things, deletion vector, you name it, performance optimization out of the box, predictive IO, etc., etc. So that's how the data is being stored in your lake house. And instead of calling it data lake house, if your data is stored in Delta format, you might call it Delta lake house. And there are other open source format also, like iSpark, which is also very popular open source format. And you would also be able to basically, if you would like to save your data in any other format, that is also possible through Azure Databricks. And also we'll see in Microsoft Fabric as well as we progress. Next is, so there you go. Now it comes Azure Databricks, which is a platform as a service data analytics within Microsoft Azure platform. It is an Azure-based implementation of Databricks Cloud Scale Analytics. It is a multi-cloud, so Databricks can work on any cloud. Azure is the first-party service in Azure. Databricks is the first-party service, which is predominantly, since you are all preparing for the DB 900, I'll focus on Azure, cloud as well, primarily, but you can also see Databricks works on AWS and GCP as well. And it's a scalable Spark. So under the hood, Databricks is using Spark processing, and it's also Spark structured streaming, Spark APIs, PySpark SQL API, and as well as structured streaming API for delivering or providing the ability to do batch processing and stream processing and whatnot in your data lake, which is the files are going to be stored or the tables are going to be stored in the Delta format. But you are free to also store them as any other format, like I said, iSpark, many other open source format, Hoodie, Parquet, WRC, JSON, Avro, etc. Okay. All right, so interactive experience so you're also going to be able to see those. So under the hood, Azure Databricks is the processing engine is Spark, and that's that distributed computing. Okay, and then it's scalable based on the data volume. It will scale automatically, and you also get that interactive experience in the Azure Databricks workspace. You'll be able to work on notebooks. You'll be able to work on SQL Editor, and you can, depending on your role, if you're a data engineer, you're going to be working on the notebooks to build your data processing logic, or you can use Lakeflow Declarative Pipeline for data processing, which are detailed on the Azure Databricks platform that you can explore. And if you're an analyst, then you would probably be using SQL Editor to do analytics. You can do dashboards, you can do, alerts, setup, everything. And if you're a data scientist, you also have that ability to use Notebook to build your machine learning pipeline, and you can orchestrate within the Databricks platform. So, and then speaking of orchestration, there are many different tools for orchestration that you have in Azure Data Platform. One is, as I was mentioning, within Azure Databricks, you have jobs and Lakeflow Declarative Pipelines, which are kind of similar to ETL or ELT that you can think. And you can also use Azure Data Factory. Data Factory will enable you to orchestrate all kinds of workloads, not only your ETL, but many other, like if you want to run another scripts or anything. So some of you might have seen Data Factory, but that's your orchestrator to implement your data ingestion and data processing pipelines. So, and then, we can dive deeper into Azure Databricks, but you got it. Basically, this is one of the solutions within Microsoft Azure platform. It is a first-party service with which you can do distributed data processing, and you can do all kinds of workload, not only data engineering, but data science and machine learning and data analytics. Next is Microsoft Fabric, which is a SaaS solution, software as a service solution. So it's basically, in this case, the solution is giving you all of the different workload that you may need in your data platform, whether it is orchestration through Data Factory, or building data engineering pipelines, or doing building dimensional data models in your data warehouse, or for a machine learning data scientist doing ML models, model training, model inferencing, and whatnot. And then, or if you are doing real-time analytics, you are bringing the data in real-time mode instead of batch mode. Or if you would like to visualize, if your role is as an analyst, then you would like to visualize the data, whether it is a batch data or streaming data. Or if you would like to set up some alert, activator is again a way to notify. So suppose, depending on anything changes in the data pattern, based on a threshold, you'd like to trigger some downstream processes or notification. That is all your activator. So you can see all of these services together will provide you any capability that you may need within your data analytics platform. And then under the hood, so these are different processing engine supporting different types of workload for different needs. And then under the hood, the data gets stored in an unified layer, which is, we call it one lake. That is basically the tables are stored in as Delta format, that the format that I talked about earlier, which is also the format for Databricks, Azure Databricks. Here, think of one lake as your OneDrive, like your data will be stored there in that one Delta format, which is an open source format. So you are not in any proprietary lockdown format. You are using an open source format, which you can again, it opens up the interoperability, right? So, and under the hood, the experience you get is SaaS experience, meaning you don't have to do the heavy lifting. You are just going to focus on your data processing logic, and everything is kind of seamlessly done. So that's software as a service product experience you get within Microsoft Fabric. And it is also integrating all the different services into that ecosystem such that you don't have to stitch together different technology stacks to enable you to do data engineering, data warehousing, data science, real-time intelligence, as well as data visualization. And then compute engine is also, you are going to get that. You don't have to even worry about the computes as well. You get unified compute, you get unified storage. Under the hood, the tables are going to be stored. Depending on the engine, real-time intelligence will store it as a, tables within the real-time KQL through KQL database that you're going to use, or for your Delta Lake, it's going to be stored as a Delta format. And you can also build your semantic model here, so business model and whatnot. Okay, so what are the things that we covered so far is the tools that you have in your hand or in your when you are working in Azure platform. What are the different ways you can build data analytics solutions? One is your Microsoft Fabric, which encompasses all of the different workloads that are pictured here. Another one is Azure Databricks, and then you also, like within Fabric, you get to orchestrate, you get to bring data in build data engineering pipeline, build analytics data model, build machine learning pipeline, build real-time intelligence and whatnot. Similarly, in Databricks also we covered that you have those capability, and it's Azure Databricks. So Databricks is implementation within Microsoft Azure. Okay. So next is there is a lab. Now, probably the time, what time is it now? 9:34, 9:24. I don't think the time for the class is going to enable you to be able to do the lab live here, but you can see that this is the link. Go to https://go.microsoft.com. And then this is like, if you search on, you should be able to find Microsoft Fabric and go to this page and start doing your labs. Let me see if I can show you how it looks like. Okay. So opening up. One more time. Nick, do the class time permits for the labs? No, right? Are you there, Nick? Okay.
Yes, no. Yes, yes.
The class time permits for the lab? No, right?
If you have time, yes, go ahead.
Okay. Okay, my mouse is okay. All right. So you're able to see the screen, right? Let me see what you're seeing. Where is the YouTube? Or are you able to see the page that I'm showing, Azure Data Fundamentals? Nick?
No, only your PPT.
Or you can only see the PPT. Okay, so then I have to reshare again. All right. So let me see. Where did this go? The YouTube. So I'm trying to see where is the. Okay, is it here? I'm kind of not able to see our. Okay, I see now. All right. So no, you can see this, right? Let me see what you are looking. Oh, echoing. It's echoing. I can hear myself. Okay. So let me try and open here. Can we stop the echo? Maybe Nick, you can mute yourself. Okay. I am going. I'm going to stop sharing and reshare.
Mm-hmm.
Okay. So this is the share rate. Share screen. Share screen. Why is it showing on this echoing continuously? Okay. All right. Are you able to see Explore Data Analytics in Microsoft Fabric now?
Yes, excellent.
All right. Now you can thank you. So that the thank you, Nick. I can you stop them? Why is it echoing? By the way, I'm not able to. Okay, fine. Not sure why is it echoing. Okay, now let me get started. It's gone now. All right. So when you click on, how do we solve this echo problem? All of a sudden it's started. Uh, let me see. I'm going to disconnect from the. I'm going to disconnect. Still going. So are you going to see hear the echo or no?
No, no, it's good. Oh, yes. Quick.
They're hearing the echo, right? What do we do? Um, Noise continuously echoing. How do I do? So what I'm going to do, is it because of the YouTube? Maybe I'll close this out. Yeah. So I was in the YouTube also. That's the reason. Okay. So let me go back and what I was showing you. That's why I was like, what the heck is going on? Okay. Now, where is our links? The PowerPoint is here, right? And go to the link. So when you come here, you can see, you can follow the instructions very easily. This lab is going to take 25 minutes. I'm just going to walk you through what to do, okay? So first is by completing this lab, this is the objective, what you're going to know. You're going to understand Microsoft Fabric Lakehouse concepts that we covered. And they ingest the data using pipelines, okay? You're going to bring the data to bring external data into your lakehouse and make it available for querying. Then you're going to be able to explore and query the data with SQL once you bring it in. And then you're going to you also learn best practices for cleaning the resources. So we're going to work with NYC taxi data set. Okay. This is going to take 25 minutes. The instructions are pretty straightforward. Here it says navigate to the home page for Fabric. So copy paste this, open it to your browser, log in. If you do not have a login created, create your own Fabric credential and then follow along. Once you log in, then you are going to be able to see this workspace on the left hand side. The screenshots are pretty self-explanatory. You should be able to follow. I'm just going to walk you through a little bit, and you can do it after the class. Click on the workspace, and then it shows you the workspaces that you currently have created. So you're going to create a new workspace, and you can see there's a button called New Workspace. You're going to click on there. You're going to create a new workspace. What is a workspace? This is your area in which you're going to be working on. So you're creating your own workspace, and now you give it a name. And suppose this is that workspace name you created, Fab Workspace. Okay. So once the workspace, so click on this, give the name, it's going to get created. Once it is created, after that, you can create a lake house inside it. So you can say that select a pre-designed task flow, or you can just create a lake house by, clicking on this create button within your Fab workspace. So give your workspace name something like this, whatever makes sense for you, and then click on this create button. It is going to enable you to create a lake house. Okay. So what are you doing? Basically, workspace is your area, your space where you are going to be building your lake house. What is lake house? As I talked about, lake house is where you're going to bring your data from all kinds of sources, batch and streaming mode, and in Delta format. And that's what you're building out now. Okay, so next is once you click on the create lake house, it's going to it'll ask you to give a name and whatnot. So finally, you can see get your data into your lake house. So the lake house got created, Fab Lake House. Okay, So your workspace name is workspace, public house. Within that, you can have your tables, you can have your files. Files could be semi-structured, unstructured data as well, and your tables are structured, right? So there are different options for you to bring the data into the platform. You can upload files, you can start with some sample data, you can create shortcut. These are things that you will learn more later. You can build data flow, Gen2, and you can also build data pipelines. So these are all the different ways to process the data and to ingest it. So, and then next, what you'd see that there are in the browser window, Explorer window, you'll be able to see your tables within the, you'll be able to see your tables within the tables folder, and you're going to be able to see the files within the files folder. Files are like if you're uploading some semi-structured data or unstructured data. If you're doing a machine learning data science test as a data scientist, if you're doing machine learning model training. Okay, so and then ingest data. So you can click on get data here, this get data button, and then that drop down is going to show you all the different options, which is nothing but this one something. And you can say how you want to bring the data in. You can say upload files, new data pipeline, etc. New data flow Gen2, shortcut, and event stream. This is streaming. Okay. So you can use the, okay, I didn't want to click on there, but maybe just click here, close it out. Yeah, so it just opened that screenshot. So let me just close this out. So then copy data wizard is going to show up. If you say copy data, it's that data wizard is going to on the in this page you're going to choose the data source. This is like NYC taxi sample data. You can choose that. You can choose other data sets, and you can see these are the format Parquet is written. So choose the data source, select a sample data. In your case, you're going to use NYC taxi green, this data set. It's a Parquet file that you're ingesting. Okay, and then connect to the data source. So you can say that within your lakehouse, you're going to create tables, and this is your table name. And the source is those files, that particular Parquet files that you selected, sample data. So you're going to select the root folder, and you're going to load it into a table. But you're going to give the table name, and you can do the mapping. Like these are the source column name, and these are your destination target tables column name. You can rename your columns. You can also decide to do some data type conversion as well. So this is kind of a UI driven, right? You're not really writing any code. So column mapping, you can leave it default as is. It's going to map it same as the column name on the source to the target. You can say load to a new table or load to an existing tables. Okay, and then enable partition, which is not necessary. If you want to do a partition table for a very, very large table, you can do that as well. This is that icon. Okay, so then say next. Once you do that, then it's creating this, this particular object where you are able to see that the copy, if taxi, give it a name, it's going to ingest the data from that Parquet sample data into your table. Once the ingestion completes, then you will be able to, within the lakehouse, by the way, all the, I would say, fabric workspace that you created, and then the lakehouse shows up in the left-hand bar. And you can go, if you change your screen, you can be able to go into that lakehouse by clicking on this icon on the left bar. Okay, so once you go here again, you can see, you can refresh your tables. Because you just created a table, you want to see it right within the tables folder. You can refresh this from here, and it will show up your table. What else? And then once the table is there, then you would be able to basically look into it. See, now it is presented in a row columnar structure. It is showing your table view, right? All the columns you just ingested. So what you did is you brought the data from some sample Parquet file into the Microsoft Fabric platform as a table, delta table within your lakehouse that you just created. So with few clicks, you could able to get all those things done, right? And then let's go. Next is querying the data lake. So now you're going to use SQL endpoint, SQL Analytics endpoint, which is to query your tables. And you're going to click on this drop down. Instead of selecting lakehouse, you're going to select SQL endpoint, and then that is going to open up, and you're going to paste this query there, and I'm going to execute it. So now here you are connected to the SQL endpoint, and you are running this query, and it's basically showing up in your query section. You can see that this is that lakehouse. You created this table, right? These are the DB or schema and whatnot. And now you are writing this query, and you can do analytics off of your table data that you just loaded. So you're just doing some sort of a group by. Yeah, I can. Let me see if it is. Yeah, you're doing a group by on the pickup date time. So you're saying for every day date name. So for every day, Tuesday, Monday, etc., what's the average distance? That, so it's an invoice taxi data. You're doing analytics off of it. Okay. All right. So what else? So next, you're just at the end, you're going to clean up the resources. It's why? Because if you want to keep them, keep them. If you want to repractice, but you can actually delete the workspace. That will remove all of the components you created, which is your lakehouse and your delta table. Okay. So this is a very short exercise, which is going to give you ability to practice to build a delta table within a lakehouse within your workspace in Microsoft Fabric. Self-explanatory, and you notice you didn't write a single line of code. It's all through the UI. So it should be low code and no code. So these are all the create workspace, create lakehouse, ingest data, query it, clean up. Okay. Now we are going to go back to the lecture. So, and then, so I covered this one. Make sure you practice on your own. Let's see, what time is it? 9:39. Okay. So knowledge check. So I'm going to go through this, even though we cannot do it interactively. So the question is, which term is used to describe an analytic solution that combine a data lake and a relational data warehouse? Yeah, go ahead.
No, it's good, it's good. Sorry.
You wanted to say something? Okay. So yeah, these are just a very brief sample questions just to get you prepared for the exam. The question is, which term is used to describe an analytic solution that combines a data lake and a relational data warehouse functionality? And there are three choices: data lakehouse, data pipeline, cloud. So the answer is already showing you data pipeline. So basically you build data pipeline to bring the data into your lakehouse, which you just saw how to build in the lab. Right?
No, I think so. It's not showing the.
Oh, it is not showing the screen?
No.
Oh, let me just go back. Thank you for letting me know. Yeah, this is the reason I never do one screen at a time share. I do complete entire screen. Otherwise, it causes all kinds of problems. Let me reshare again.
Yes, please.
Thanks for letting me know. So share, where is the share? Okay. Share screen. This time I'm going to do share entire screen because otherwise it's waste time. Okay. So hopefully everybody is able to see my screen, right? So I'm going to go to that one.
Yes, yes.
To the presentation mode. No, this is not the slide on which I was. I was on the, how come it did change it? So let me see. All right, I'm going to go current slide, but I know we moved further, and let me go to that spot. Okay, so first question, what term is used to describe a solution, analytic solution that combines data lake and a data warehouse, relational data warehouses functionality, which is your data pipeline, which is how you're going to bring the data to the, like your not only your semi-structured data to the, but your unstructured data, so all kinds of data you're going to bring into the platform, to your data lake or delta lake house, and to your relational data warehouses. Yeah. What must you define? That's the answer. What must you define to implement a pipeline that reads data from Azure Blob Storage? So you're going to be defined what is Azure Blob Storage. That is, again, as you deep dive, if you are new to the Azure Data Platform, it's basically your storage buckets or within where the data files get stored. So blob storage, how do you connect to the blob storage from your pipeline is the question. The answer is you're going to create a link service within your Microsoft Fabric. You're going to be creating the link service, which is going to connect to your blob storage account. So you're kind of connecting, linking to a storage account from where you're going to read the data files for ingestion. Last question, which open source distributed processing engine does Microsoft Fabric includes? So I think we already talked about it. Distributed processing engine, meaning parallel processing, remember? So that's Apache Spark. Okay, and that is also the distributed processing engine for Azure Databricks as well. Okay, streaming and real-time analytics. Next, we are going to go to the streaming analytics. Streaming means basically, as I was mentioning, like there are, as you bring data to the platform, to your analytics lakehouse platform in Microsoft Fabric or in Azure Data Bricks, you will have need to bring data in many different frequencies. Like some of the source system data or use cases may require a batch processing, which is you are scheduling it to run every few hours. Here the latency is more, right? Because you're basically accumulating the data and only processing it in that particular triggered frequency. So batch processing you must be familiar with, right? You define a window of batch. It could be every night, and you accumulate the data in the source system, and then you ingest it during that time, all of it, process it, and roll it to your analytics platform. Okay. Here the data is collected and processed at a regular interval. The interval is that trigger frequency that you define. Whereas stream processing, so you think of it like you're counting cars. So all the cars, you count it and then you store it. And that is you're letting those cars accumulate. Maybe this is a parking lot picture or something like that, and you count them, right? And then that is you're counting every hour or so. So that's your batch processing. When you are doing stream processing, basically as the data is originated in the source system, you're going to ingest it and you're going to immediately process it. Here you are actually doing a continuous processing. So and you are also not waiting to accumulate the data um, in a longer window, right? Here it's going to, as the data is originated, you're going to be processing it in your and bringing it into your analytics platform. So it supports that near real time or real time data and bringing the data into the platform. As the data is created in the source system, you're bringing it in a low latency frequency. It could be seconds, it could be milliseconds, it could be microseconds, it also could be minutes, depending on what you need. Now, streaming does not have to be real time. Normally, streaming is used for near real time or real time, but it means continuous processing, like you're defining a pipeline to bring the data in a continuous fashion to your analytics platform. And so this is what we are going to cover. Data is processed in near real time as it arrives. Common elements of stream processing is like, first thing is, where is that what is the stream? Like basically if you want to think of it, where is that data going to originate from? So think of all of the wearables, devices, smart meters, connected buildings, smart thermostats, your Fitbit, your Apple Watch, any manufacturing plants, every equipment is now smart or digitized, right? Which means they are all emitting telemetry. So those telemetries are events, and that is one source of streaming data. Another one would be your Azure Data Platform or your Azure infrastructure, your compute logs, your application logs, and any audit events, anything that is getting generated as the processing infrastructure monitoring. All of those are also continuously generated data that is considered as a stream data that you are going to bring in into the platform, and we are going to learn how to bring what are the different services available for stream processing. So stream is the world where you are bringing the data from devices, from application logs, from infrastructure logs, even from operational databases. So suppose you have operational databases which are maintaining your OLTP system, which is the backend data for your maybe for your portals, maybe for your operational applications. Now those databases are optimized for DML, like they are OLTP, online transaction processing system, right? From there, as that changes are happening to the databases, which is insert, update, delete, you can get those as a change data capture also and bring it to your platform as a streaming processing. And your goal is to get the data from operational to analytics for analytical purposes, right? Because operational databases normally won't let you connect to them directly to do analytics. Okay, so these are all different cases of stream processing. And basic idea is stream is low latency, could be low latency, may not be low latency, but is the continuous processing. If you like, whenever a data, think of these devices, they never stop emitting telemetry. Think of the application logs, they never stop generating logs. Or even your operational databases will never stop creating change data capture. So those continuous stream of data that you're going to bring in. And the data is captured in a streaming source for processing the day. We call that stream events or transactions or telemetry or just change data capture. So that data is processed, and you need ability to be able to process it in your analytics platform, which is within the Azure. What are the possible services that you have that we are going to see? The results of the stream processing operation are written to an output. So basically, as the data is ingested, you would like to ingest them and write them to a table, which is delta table we are going to see. So real-time analytics is the term that we use for streaming analytics. It is saying real time, but it doesn't have to be real time. It could be continuous stream of continuous data stream coming in. Okay, it supports for continuous data ingestion from multiple sources, and I talked about all the sources. Capture streaming data as an event stream. So event stream is a service. So you can see this is the Fabric icon, and this is basically real-time intelligence icon. The earlier name was analytics. Now it is real-time intelligence, and within that you have the event streams key component, which will enable you to capture the events or transactions or change data capture or telemetry into the platform. So you're going to ingest this with the event stream, and then you're going to store them into your KQL database or lakehouse table. Lakehouse table is your delta format table, delta tables, and KQL database tables are again optimized for high volume, high velocity streaming data. Again, KQL is the language, programming language, Kusto query language. Similarly, when you use delta tables, you are querying, you use SQL, right? Here you use KQL. Very similar, a little different, but it's also optimized for processing telemetry data, time series data. Okay, write real-time data to a table in Lakehouse or to a KQL database. So it's up to you where you want to write it. You can write it to KQL, and then you can also, make it available to your Lakehouse as well as a delta table. Query real-time data using SQL and KQL. So the goal is basically, as the data is getting generated, you ingest it to the event stream, and immediately you would be able to get insight from it after you store it or while you're processing it, transforming it and loading it to KQL database. At that time, you can do whatever you need to do: joins, data type casting, duplicate removal, group by, etc., aggregate tables, etc., that you can do. The query real-time data with these two programming language, build real-time visualizations. Also, you can use within real-time analytics, you have a service called real-time dashboard, analytics dashboard, that enables you to build visualizations with this data stored in KQL database, or you can use Power BI to connect to delta tables as well as to your KQL data sets to build your visualizations. Okay, data analytics with Spark. So again, we are going back to the Spark processing engine. Let me see here. So again, remember we talked about distributed computing, which is the open source Apache Spark. And how basically Spark is the underlying compute engine. I already spoke about it under Microsoft Fabric as well as Azure Databricks. So it is a distributed processing framework for large scale data analytics or big data analytics, because the volume of the data is going to be very, very high. You cannot scale the compute on the vertically, so you're now distributing the workload or the data partitions horizontally into different worker nodes to get that performance, parallel processing performance improvement. Okay, you can use Spark on these two services. And then within Spark also there's an API called structured streaming, Spark structured streaming, which is basically there's documentation. It has a huge verbose documentation in order for you to be able to use that Spark structured streaming API to do all kinds of processing. That is a library which provides an application programming interface, which is API. Now we use API for everywhere, right? Whenever we are connecting to any system to get data, to send data, it's all about API, application programming interfaces. So you're going to be, that is structured streaming has a lot of APIs that you can use to bring the data, ingest the data, to process the data, to write the data, output the data into streaming table or your delta table. So that is your Spark streaming is the API for processing. Under the hood, it is that distributed computing, and that data is getting written to the delta table and a delta lake. Like delta Y delta lake is the data lake. It's under the hood, it's storage account, EDLS Gen 2 storage account. But you have the delta optimized storage engine layer, which is that open source format that's giving you ACID transaction, ACID transfer, atomicity, consistency, isolation, durability, time travel, version control, what else? DML, performance optimization, out of the box performance optimization, etc., etc. There are numerous. If you go to delta.io, you'll be able to read those. I will see if I can show you that as well. Okay, Delta Lake can be used in Spark to define relational tables. So what is this Delta Lake? So under the hood, they are actually files, Parquet files. And Delta is the optimized storage engine or storage layer, which is sitting on top of those Parquet files in the EDLS Gen 2 storage account, which is giving you this ability for asset transaction, for time travel, all the features of Delta. Okay, and it is also giving the ability to ingest. It doesn't have to be batch. Delta table you can write to all workload. Whether it is streaming, you're ingesting the data in a streaming mode or in a triggered frequency mode, batch mode. Either way, you can store the data. So you can ingest it and process it with the Spark structured streaming API and then store it in the Delta Lake, Delta table. Okay, so there is a lab for this also. Let me go to that lab. And I'm going to close this one out just to reduce. Okay, so here in this lab, you're going to be exploring the real-time analytics within Microsoft Fabric. So this is 30 minutes. We are not doing it live here, but you can do it. I'm just going to walk you through all of the steps. So again, same concept, right? Remember everything. Last time you started creating a workspace, here also you're going to start creating a workspace. Go to the Fabric homepage with your login, and then you know how to create the workspace. We covered it in the previous one, right? So you're going to go, and here you're going to say create the workspace. This is your workspace. If you have already created in the previous one, then you can just continue to work on this one. Then you're going to create an event stream. The event stream is a service to ingest the events or transaction or change data capture from the source system. So it's basically your under the hood event stream is earlier it used to be the Azure Event Hub, IoT Hub, and Stream Analytics combined together is now event stream. Now event stream is just to capture the stream of data. It's not for storing it permanently. You're going to be storing it in your KQL real-time analytics, real-time intelligence database data sets, or you're going to store it in a Delta table. Okay, so when you work on this, you're going to be working on the real-time hub. So you can see this icon. This is the real-time hub. So you can see this is that showing your real-time hub. So all of the streaming analytics, when you are working on within Fabric, you're going to be working on the real-time hub. So you can connect to data sources here. There is again sample data sets. And first time you're going to see that real-time hub. So within your workspace, so you're within that. Remember, you created a workspace, and now you're going to work on the real-time hub for your streaming analytics. And what else? So you're going to connect to the data sources, and there are numerous possible options. You can see Microsoft sources or database change data capture, CDC is change data capture, or Azure events like your infrastructure events, system log events, Fabric events. Like within Microsoft Fabric, all of the services are generating events like blob creation, any numerous. You can go and explore all those sample scenarios. Public feeds also you can bring in. So you're going to go here, and then let's see. You're going to select the yellow taxi. So you can see there are some sample recommended data sets so that you don't have to worry about uploading files or connectivity if it is not established. This lab environment makes it easy for you. You can connect to those sample data, which is bicycle or stock market or yellow taxi. Select the yellow taxi and then connect. Okay. So now you're basically going to ingest. There is the connect button. Ingest the data. This is simulated streaming data. So it's kind of the curriculum is already created this simulated stream yellow taxi streaming data continuously generating. You're going to be continuously ingesting it. So you're going to build a real-time intelligence pipeline, and then you're going to be able to ingest it through event stream, this data. And as it, like once you keep it running, it's going to continuously get new data flowing in. Okay. So you can say that, so this is your sample. You're going to write it to or ingest it through that event stream. This is that icon of event stream. And then remember, you selected that event stream name, you're giving it a name, taxi data stream. Within this workspace you are working, and your stream name, your event stream name, you give all those things. It's like basically next, next, next. Very simple. You're not writing any code, or you're not writing any programming code. If you don't need to be like, if you even if you don't know programming languages, you should still be able to do this. Okay, so the next, so then you click on next, and it's going to establish this kind of a pipeline. So you see, this is your sample data, and you created that event stream. So this the stream, there's the sign of event stream. And now next is what you want to do with this. So event stream captures the data from that simulated taxi events, that is generated data or simulated data that you are ingesting it. And it's going to be, once you click here, you can see the preview of the data, how the data looks like that is getting ingested. And then you can also, after that, you want to persist the data. Where do you want to store it? So store it in an event house. Event house is within real-time hub, the like data warehouse, we call it, right? Data lake house. Similarly, event house is for event streams. So event house you create. So you can see, you can either create the event house earlier. Here you can, within the hub, you can say create button, create event house, and it's going to, go through the steps. And you can see here, event house, you created the event house. Within that, you will have your database. So this is your KQL database, my event house. Within that, your table, like the taxi data that you are ingesting through event stream is going to get written. All your, tables. You can create multiple data sets or tables, whatever you are going to call it, and you can use KQL language to, programmatically query those as well. Okay. All right. So this is your event house. Within that, you can have multiple databases and whatnot. And this is that system overview. It's showing, like, when you first create the event house, it's going to be empty, right? And then it's going to fill up as you progress, as you ingest data. So next is in the pane, you can see, so follow through the instructions, and so now you have a event house and a database created. As the event house gets created, it also creates a KQL database together. Then you're going to use that as a target. So you're going to say, you can go to that particular event house, like my event house, you gave it a name, say get data. And then you can say, okay, I want to get the data from this event stream. Remember this event stream you created earlier? Or you can, if you have created the event house before, then you can directly do it as you are progressing and you are writing it here. At that time, you can select the event house and then particular database with the next, and you'll be able to write there. Okay, so the goal is basically get that event stream ingested, capture it through the event stream, like get that stream of events ingested, capture and ingest it to the event stream, and write it to event house KQL database tables. Okay, so that, like, either way you can do it, whatever options you want to, like however way you want to do it. This instruction says that, okay, first bring the data, set up the event stream, then go create the event house, create the event, create the KQL database, then connect, get the data from that event stream into the event house. So here you're saying your event stream name in this, your connection name is this taxi table that you created earlier within this workspace, and go ahead. And then after that, you're basically connecting it. And now your taxi data, simulated taxi data, is getting written to your taxi table, which is within the event house. This is your streaming table. Okay. And you can have, there are lots, I can talk about it here, but this shows or your, like, the data set size, original, compressed, etc. And how the data is, like, this is kind of a progress as the data every day gets incoming streaming data is coming. It's going to show you the volume, it's going to show you the size of those tables, and etc. Okay. And so this is now your kind of flow is established. Your source, this is your simulated data, your event stream capturing the data, event house table is loading the data or storing the data in the optimized format, which is for telemetry, time series analysis, streaming analytics. Okay, what else? So query. Now you have captured the data. Now you want to query the data. So you created a taxi table. Okay, I think you gave the name as taxi here, remember? So that table now you're going to query. So you can come here and you can say, follow the instruction. This is the KQL query language. You can give the table name and say take 100, meaning you're basically doing a select 100, top 100 from the table or whatever. Okay, so that is how, very simple, similar to SQL syntax. All right, so you're going to do that in that query window. So you can basically see this is your table. You're querying this table and your query name is this one. You gave a name of that query set. We call it query set because you can create multiple queries within this kind of editor. Okay, so that query editor, and you give it a name that shows up in the query set. And then review the results. So now you want to also not only do just a sample check, you want to do some sort of a aggregated analysis. So you can do summarize. These are all similar to group by. You can say summarize, count. So basically you're saying group by, like you're binning it on a particular pickup date time. You're taking the converting it to date time every hour. You want to see how many pickups has happened and whatnot. So whatever it is that you need to do, and there are numerous documentation. You can search on Microsoft Online documentation. You'll be able to see sample syntax. You can just copy paste those and modify it for your table purposes and play with it. And then after that, what is, yeah, so this is basically nothing but you are doing a group by for every hour. What is the total number of pickups? Okay, so highlight the modified query, run it, and then what is, wait for a few seconds and run it again. You will see that the count is changing. So just to make sure you understand that this is actually not a static. Your basically your data is continuously coming in. You built a pipeline, right? This is kind of, think of your streaming pipeline. You establish that connection. You're ingesting through event stream from the source. The source data is automatically continuously generating. You're writing it to this table. If you run this query in every 5 minutes, you'll see that the counts are changing. That tells you that they are live data, the streaming data coming in. So the table gets updated or insert new rows gets inserted to this event stream as soon as generated data is being captured as and when. So this is a sample data set, right? In your real life, you're going to set up like kind of message pops up service through maybe IoT hub, event hub, etc. And you're going to get the data into through the event stream, and I'm going to write it to the KQL database, or you can write it to a lakehouse table, delta table as well. And you can also use Azure Databricks to also bring the data from all of these different types of sources through message pops up services like Kafka, Kinesis, Event Hub, etc., as well as from change data capture from your operational databases, from your cloud object storage, which could be your ADLS Gen 2 or S3 bucket, whatever is your source. And in our case, we are talking about Azure, but if you are multi-cloud, you can also use other storage account from other clouds as well. Okay, so query the data we saw, then group by and analytics, right? And then clean up the resources. So these two labs, what did you do? Just to summarize, the first one showed you to create a pipeline where you are basically learned every time you're creating a workspace, then you're creating a lakehouse for your batch processing. So your lakehouse, you're going to get the data. In this case, you got some sample NYC tax data. You created with some like wizard driven, UI driven, right? You created a data target, source and target copy data activity. You're copying the data from that particular sample data set into your table, which is a delta table. After you ingested, you queried the table through the SQL endpoint, did the visual data analytics off of it. So you brought the data. This is going to be your batch mode. But when it comes to streaming, then you're going to use this streaming analytics, right? So this is also very similar. And you worked on your own workspace. In this case, you're creating a real-time hub, not lakehouse. Okay, within real-time hub, you're capturing the data through event stream. Then you're writing it to the KQL database. You can also write it to delta table as well if you want to. Okay, so those are the two modes that you also learned to do in the lab. So it's not only the I would say lectures, but this backs your understanding of the lectures. So as a data engineer or a data analytics or a analytics engineer or a data practitioner, you can use these services to bring the data easily into the platform, whatever is your use cases. I would say ingestion mode, whether it is batch or streaming, all of these are available in your disposal or in your fingertip to be able to use, whether it is Microsoft Fabric services or it is Azure Database services, but everything is also within Microsoft Azure platform. Okay, so now let's check. Which definition of stream processing is correct? Is it data is processed continuously as new data arrives? Data is collected in a temporary store and all records are processed together as a batch, or data is incomplete and cannot be analyzed? Obviously, it's very obvious, right? So data is processed continuously, like we saw the simulated taxi data. And once you establish that, flow, and you are writing to the KQL database, it's going to be continuously new data as it arrives. It's going to be written down. New records are going to be available for your analytics. So the first option. Next is, which component of Microsoft Fabric provides a central place to manage streaming data? Real-time hub. We saw that, right? So for streaming, it is real-time hub. For batch, it's lakehouse. Okay, those are the two. Okay, so next is data visualization. So now we have about 21 minutes. I think that's good enough. Okay, so data visualization is basically, now that you brought the data, you brought batch mode, you brought streaming mode. Now you want to get insight from the data. As a human beings they can glean information from data, not by reading like hundreds of millions of rows, but basically through visualization, which makes it easy to perceive the information, right? So start with Power BI desktop is one way. You can import the data from your sources. Those data sources could be your Excel or SQL Server, Synapse, any cloud object storage, any flat files, etc. So Power BI desktop is this is going to run on your desktop, right? And you can publish those to Power BI service. And Power BI service, you can consume it through the web browser, or you can also consume it through Power BI or phone app. So Power BI is your visualization tool. Desktop is the desktop client. Service is on the cloud. Like you can publish it to the service and then consume it through the browser. Makes sense? So and then what do you visualize? You can visualize like ad hoc files, or you can connect to your lakehouse, to your KQL data sets that you built, and then visualize it through Power BI service. So import data from one or more sources, define a data model. Now within Power BI also, you can do a semantic data model, meaning you can also create, like we talked about dimensional data modeling, which is star schema, snowflake schema. I don't think we went to the detail of those, but basically when you are doing analytics, you are working off high volume data, right? And then you also want to get summary statistics. You want to slice and dice the data. That time you build dimensional data modeling, not relational, dimensional. And that is most of the times star shape or snowflake shape, meaning you have transaction tables. Those are your facts. You aggregate the transactions into different grain based on your dimensions, which are your contextual information. And that's the reason you're going to build or store the data or create a model on top of your underlying data tables, whether it is KQL or it is delta tables. You're going to build that dimensional data model or star schema data model on top of it, so that it is performantly optimal for this type of visualization analysis through Power BI. So you can start with Power BI desktop, create the visualization, publish it to Power BI service. Service is basically its own cloud. You are going to be publishing for consumption through app and through browser. Schedule the refresh. You can also schedule the refresh. So when you are publishing in the Power BI service, then your source data may not be a static data, right? Because you could be connecting to your lakehouse delta table, and you could be connecting to your KQL data sets as well. So you would like to get the data refreshed your dashboards, like as the new data shows up in that particular source table to which you are connecting, or set up tables that you would like to refresh. So you can schedule the refresh in that Power BI report within the Power BI service. You can create dashboards and applications, and you can share with them with others as well. Okay, and you can interact with those. Those are interactive visualization. You can change them based on your need. Like you'll get the one visualization of you want to filter it, drill down, drill up, whatever it is that you need to do. You are free to do that as well, and those are all through the like this is again the reporting interface. It's not that you're writing some code or something. It should be pretty self-explanatory and easy, even if you're a non-technical user, if that is the case. Okay, interact with your published reports with your web browser or with your Power BI phone app. And this is the service or very popular visualization service within Microsoft Azure Data Platform. And as I also want to mention, there is one more service called Real Time Dashboard, which is part of your real time analytics hub. Within the real time hub, as you store the tables in the KQL dataset, you can also use real time dashboard, which is within that real time analytics scope of components, key components, to visualize your data. And that's going to be more closer to your data set. So it's going to be even more, I would say, less latency. You can also do complex visualization in your Power BI reports. So analytics data modeling, this is again, we are going a little bit more onto that dimensional data modeling. So suppose you are, every company has sales transaction, like almost every industry, like so everybody is selling something, right? And then basically whatever they are selling, it is a retail or it is a manufacturing company who are manufacturing products and then selling it, right? So there will be transactions. Those are sales transactions or claims processing transactions or anything which is basically, source of truth. Basically, these are facts. Why facts? Because they are, once it has happened, they are true. They are not to be modified. Okay, so your facts. This is your main, I would say, business matrices is going to come from your facts, and facts needs some contextual information to get meaning, right? Okay, so we talk about this. This is the timestamp, and this is the revenue for these customers, and so these are all keys. So you can notice that this particular table is showing product key, customer key, and then its own surrogate key. We call them surrogate key. They are basically primary key, an auto-generated number. So sales is your transaction. Suppose this is a retail example. Okay. So you have your sales transactions in your sales tables. That's the transaction table. And you have your customer dimension. Like, who are your customers? They have their, like when a customer is making a purchase, they have to enter some of the details, right? Most websites, if you go to Walmart or Amazon or any portal, any retail, you'd see that you have to enter your information. You create a profile, you add some bare minimum information. It could be your address information. If it is shipping, the products needs to ship, right? So those address information, sometimes even credit card information you save and whatnot, right? So that's your customer dimension, details about the customer. Then every like whether it is a retail or whether it is a manufacturing company or any insurance company, they will have products, right? Products means what is it that you are selling. So products again is another. So you see, a transaction is tying everything together. So a transaction is created by a customer related to a product, meaning a customer is making a product purchase, and that is ultimately a transaction, and that has a dollar value. Okay, so that's your revenue. So product is another dimension. Product dimension is like basically what are the details of the product. So whatever you are purchasing. So if this is a retail example, you as a customer purchasing something on the portal, and that is captured as a transaction, sales transaction. And then when are you purchasing? Like basically every time there is a transaction happens, there is a timestamp component of it, right? So now time is very critical because whenever the company whose products you're purchasing, they want to do analytics. Like when they want to do analytics, they want to check the, like, get insight from the data in many different grain of time. It could be hourly, it could be every 6 hours, it could be daily, it could be weekly, it could be weekdays or holidays. So all of those are like, the time dimension is a critical dimension because you want to slice and dice the data based on times, right? Timestamp. Now that's why always every analytics data model will have a time dimension or calendar dimension. That dimension is nothing but it's like your company calendar. Like every day, what year, like you can, these are very typical, you can just find it online. So many, every single analytics platform will have that. Is basically the key is the date time, right? And then it will broken up date, year, month, weekday, and holiday, etc., etc. You have your company calendar. So normally, and your standard calendar, fiscal calendar, annual calendar, all merged together. Basically, you build your time dimension, and that is also going to be connected to your transaction table, which is sales transaction. So this is how the dimensional data model looks like. And yeah, and so you can see how it's shape of a star. So if you think like inside, this is the fact is at the center, the dimensions are kind of branches connected to the fact, and they are related with primary key, foreign key. Now we don't enforce the primary key foreign key relation, but you enforce it programmatically. So you load the, like you load the dimensions first, and then you load the corresponding facts. So you get the keys and whatnot. There are a lot more detail to go through that, how you load the data or refresh the data into this dimensional model from your base tables. But this is how you model your data for analytics ready, for visualization ready. And that you can do it in the semantic model within Power BI. You can also do it in the lake house and the gold layer. So, okay, when I say gold layer, basically medallion architecture. So as you process the data, you ingest it, then you transform it, you clean it, you standardize it, enrich it, and then you make it clean data. That is your silver. So first you ingest it, that's your bronze raw ingestion. Then you do all this cleansing, that is your silver layer. After that, you do aggregation or you create that model, data model, which is dimensional data model, star schema or snowflake schema. What is snowflake schema? Snowflake schema is also star schema, except these dimension tables can have hierarchy, and those are going to be like a snow, like the way a snowflake looks like. It also will have branches to it, like the hierarchy. Like suppose product have different product categories. So you can drill down, you can slice and data onto those hierarchies as well, or roll up or roll down, or drill down or roll up. That's what we call it. So that is possible with this kind of a data model, star or snowflake. Okay, so I know I didn't cover medallion architecture, but medallion architecture is a conceptual architectural model to process the data. The goal is to ingest the data and make it clean and standardized, conformed, and I would say all data quality rules validated, and then available for consumption for analytics. And then you do the dimensional data modeling. And the why do you do dimension data modeling? Because you want to slice and dice the sales revenue based on different dimensions, like which product, which customer, who is my most, like high, like who, which customer is purchasing, making the most purchase, who is bringing the most revenue, which product is the most sold product, and when is, like, is there a seasonal pattern, when is it that the purchases are happening more, right? Those are the things you can do with this kind of a cube. Like you can say this is the cube, like the cube has different like I would say each arm is another dimension. And then the facts are basically that point where they are intersecting. That is your revenue. Think of it. These are all the dollar amounts are going to be in the transaction tables. Okay, so then time dimension, yeah. So if you want to do a slice and dice the data, you can say, okay, for each year, for each month, for each day, I'd like to see the total revenue. So you're aggregating the data on this calendar dimension, or you're aggregating the data for customer dimension or for product dimension, etc. Okay, so common data visualization is you can do tabular representation. Tabular representation is only possible when you have less amount of categories, right? It is not it's not going to fit in into your report, and also not going to be very much insightful if it is a long list. So in that case, you would like to visualize it with the bar or column chart. And then line chart is mostly like trend analysis, like time series analysis, right? That you can do how the revenue is changing based on the day, month, etc. Then pie chart is basically which product is selling more, which product is bringing me more revenue. scatter plot is also like how much is the spend versus revenue, like how much money I'm making and how much is the spend, marketing spend. Like suppose a company is doing marketing advertisement, marketing that's an expense, right? So if I'm doing my product marketing, is that really translating to additional revenue or not? So those type of things you can visualize through scatter plot. And map is again very useful for geospatial representation. Like if you have latitude, longitude, if you have location involved, then you'd like to use this map visualization, which are very attractive as well. And every company, every has a geo presence, right? It has physical store location, it has physical supplier location, logistic location, warehouses. So obviously the map representation is, and customer location also is very useful. Then visualization again, let me see if I can quickly go through because there's only 7 minutes left. Okay, so you install Power BI desktop. So this is that desktop application. You're going to install it. This is the download link. And then after that, the Power BI, once the installation is complete, then you can open it up and you can say get data. And in that get data, there are many different sources that you can bring the data from, get data from other sources. So you can connect to Wave, all those things, and you can say connect. And you can see this is just a snippet. And there's huge list. See this scroll bar. Okay, so a huge list of sources you can get the data into your Power BI desktop. And here in this case, you're going to choose web and say connect. Then you're going to pass this GitHub. You're going to basically, the CSV file is sitting in a GitHub repo. And you're going to ingest that into Power BI desktop. Say connect. So now it loaded that CSV in your Power BI data model. So it's showing us basically these are the 5 columns, 1, 2, 3, 4, 5. And it's just giving you a preview based on the first 200 records. Okay. And then you can start doing it. So here you can say get data wave, and you do your visualizations here, which is in the main Power BI. You can select that is get data and select the corresponding application, like source from where you're going to get the data to visualize. And we already gone through all of those before, right? And then after that, repeat that for multiple data sets. So you're bringing customer. This was the original one, was customer CSV. Then you're bringing order. Then you're bringing, I think the last one, what did I say? Order, product. I think so, right? Order. What was the other one? Products. Yeah, so you can connect to different, I would say CSV file. This is an example in which you're going to be practicing with CSV from a GitHub repo, and bring those in. Now within Power BI desktop, you can establish relationship between them. Like, and this is your transactions, like order transaction, customer. So whatever we just saw, customer is a dimension, product is a dimension. You're going to connect them with this, relationship. You can see that model view. Let me see if I can click on this. So this is your one dimension. This is your other dimension. So it's saying order item ID. Item ID is again basically product, right? And then your customer ID that is related to the customer. The primary key in the customer is connected as a foreign key in the order. Primary in the product is connected as a foreign key in the order table, etc. And then item also will be there. So this data model you can build in the Power BI desktop. We call it semantic model. You are establishing the relationship between different data sets. Okay, and next is, then, yeah. So the way you do it, you basically, so revenue is, you can also decide what would be the revenue format. You can say this is currency, data type. So you're going to do this kind of presentation layer within your Power BI model. You can say, okay, whatever data type conversion you want to do, etc., etc. What are the things that, so you're going to be aggregating the revenue, quantity, etc. within this, Power BI semantic model, and you're also going to be establishing the relationships between different dimension tables and fact tables. So now so now here it is saying you're basically also creating a hierarchy for the product. So you can say it has an option, category, product has a category has a hierarchy, and that also could be established here. Okay. Next is because those based on the different hierarchy, you would like to slice the data, right? So then what else? So in the product, you can have the product name, add hierarchy, add to the hierarchy, and then corresponding every product will belong to a particular category hierarchy, and that you can map it here. Okay, next is fields. So you can also rename fields. In the fields pane, you can right click and rename the fields, whatever. So this is the presentation that is going to show in the report, and you are preparing it in the desktop semantic model. Okay, and then what else? The screen is showing you. Yeah, so as you can say that city, each column uncategorized. So whether you want to summarize it or what do you want to do. So based on the instruction you're going to follow through, select the table view, data pin customers, select the city, set its data category, property to city, etc. Okay. Follow through these instructions. Oh, 2 minutes. Okay. Then security. So basically security is go to files, options, security map, etc. etc. And you can say basic check, and you can define the security like uh, certificate revocation. So it's not going to really do a basic check. Require user approval for new native database queries, etc. So this is where you're going to set up the database query security, and you can say map and field map visuals, etc. So follow through this. 10:29. I think we are coming low in the time. So in the report view, this is your data model that you just prepared, and you're going to drag and drops. You can do all of. You can select what kind of visualization you want to do, and then create your visuals here. And then you can, once the visuals are ready, when you scroll, this is like a tabular report. This is a bar chart. This is again also a bar chart, and your pie chart, and then your map visualization. And then once you have it, all you can put filters. They're also going to work as a cross filter, and then you can publish it too, and you can save it. And then if you have a Power BI subscription, you can also publish it to the Power BI service from the desktop. Okay, so that is the exercise. So what you're going to do, install Power BI desktop, import data, explore the data model, create report. Okay, with that, let me see, 10:30. All right, so Nick, are we over time? I think that's it. That was the last slide. Yeah, so there are a few knowledge check question. I can just go through real quick. Which tool should you use to import the data? Power BI desktop you're going to use, and create a report. What should you define in your data model to enable drill down? Yes, basically drill down meaning a hierarchy, right? Or up. What kind of visualization should you use to analyze pass rate for multiple exam over time? Okay. Yeah, meaning over time. Whenever you say over time, it's a time series. So line chart is the best. Run chart or line chart. Okay. So that is it. Okay. So now I'm going to stop sharing, and I'm going to have Nick, are you here? Yeah.
Yes, I'm here. Okay, fantastic, Mo. Spending any topic about the PPT or
Yeah,
no?
so I would say, though, if anybody is watching this offline, just practice through those labs, go through the material, and we are going to publish the lecture slides somewhere, right, in our repo, and then you can probably be able to access those and practice. I would say that will enforce your learning. We are going to come back again with more and more content deeper into other different areas. Okay, with that, I'm going to say thank you, everyone, for your time. Nick, thanks for your time as well. That's it. I don't have anything more to say, add to this.
Okay, Mo, thank you so much to join us today. I know many people is maybe on vacation for the long weekend, but in offline it's possible to get more views to this session. Amazing, Mo. About the community, thank you so much. The expectation is to come with you for another session, another topic, maybe Databricks, because you are an expert at Databricks. And many
Yeah.
people is interested in Azure Databricks, no? The many technology, to connect with Microsoft. And thank you so much again. Thank you, community. See you in the next session, in the final session, to see the attest a certification question with me. This is the last session. Happy to join us in the next month with the community again. Thank you, Mo. See you soon.
Thank you, Nick. Thank you, everyone. Bye.